Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 944 rotting oranges. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes before jumping into the solution. So let's get right into it. What problem is asking that you are given certain three state. First one is empty cell denoted by 0. One is fresh orange and second one is rotten. So you have to return how much time does it take to rot all the oranges, and there is a certain condition that if one orange is rotten, it will rotten all the fresh oranges in the four direction. These are the four direction: left, right, top, bottom. These are the four direction in which if there is a fresh orange, if there is a fresh orange, they will be rotten. And how much time this take is 1 minute. So in the feasible four direction, if there is a fresh orange, in 1 minute it will be rotten. So we have to return in how many minutes will all fresh orange will be rotten, and if it is not possible, if some fresh orange is left, you have to return -1. I hope this much is clear. So let's take a test case to have more understanding. I'm making that test case only, the above one. It is a 6x6. This one and this one is rotten. Given how we see rotten when it is 2. Let me write 2 over here. 2 1 1 1 1 1. So this much is clear. Let's take another pen. Yeah, for very first minute it will go this, this, this. These are not feasible, out of bound. These two will be rotten. No, 1 minute. 1 minute we have took. Now in another minute, what these two will done? Not done. Will do same thing. This will also get rotten. But as you can see, only the right and only the down was the feasible action. These action didn't count because this out of bound, this out of bound, this is empty, this is empty. So only this counts. And now how much time we took is 2 minutes. Let's change the pen. And in this we will do this again, up and back. Why will not go to back? Because obviously we will have something called visited. That's why in this third minute, how many orange are rotten? This orange. In fourth minute, what will happen? This is not valid, this is also not valid, upper is not valid. Which one is valid? This, the right one. And this orange is also rotten. Everyone is rotten. Let me change the pen. This one is rotten now. This one is also rotten. 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 Any left? No. So what we will return is true. Not true. We will return 4 minutes. We will return 4 minutes. So that is what problem is. So now next thing is how to approach this. As you can see, we have to move in 4 direction. That much is clear. We have to move in 4 direction, but in a constrained way. What is constrained way? That we have to process all the valid direction in one go. What do I mean? For example, we have orange in this direction only, and this go out of bound, so they don't imply, but they do imply. These we have to take care of, and these two will will be taken care in 1 minute only. So that is possible only when we process one level full. In which traversal we process one level fully. In which process, in which traversal that can be done? I think that is BFS, breadth first search, not DFS. What DFS will do is, we are at this node, DFS will go at this node, will go to another node, will check this side, then go to other node. But what time we will get is not the one, not the minimum one. Why? Because it will traverse here and there. It will not traverse like all the 4 direction in one complete go. It will not process all the oranges present at 4 direction in one go. So that's why BFS. And why traversal is used? Because you can yourself see we have to go in 4 direction. How you can go in 4 direction? Very basic thing. Without traversal, it is not possible that you can go anywhere on 2D matrix. How is that possible? Only possible using traversal, and we know only 2 traversal, BFS and DFS. So I already told why BFS, because we need controlled traversal. Whenever there is controlled thing, what do I mean by control? That in this case, in 1 minute, we required all the 4 direction fresh oranges. But that will not happen in DFS, because DFS gets into depth. It will just go into other node. It will not process all the nodes simultaneously. So that's why BFS is used. I hope that much is clear. So now, how are we gonna apply BFS? How are we gonna apply? There are 2 options. Start from fresh or start from rotten. You yourself answer which is easy to handle, rotten or fresh. Not easy, which is predictable. I will say which is more predictable, which comes intuitive to your mind. I will say start from rotten. Why? Because you for sure know that in this direction, if there is a fresh present, it will get rotten. But when you start from fresh, you will have many variables, 0, 1, 1. After that, sometime you encounter a rotten, but how will you go back in the past? Because if this is connected, this will be rotten, and this also should be rotten. But that is very difficult to think and to handle. So this is no for us. This is the way to go. So we will start from rotten. So what would be our algo is that first thing, collect all the rotten in queue. Why queue? Because we are doing BFS, and also I did explain why we are starting from row 10 and why we are correcting in a queue, because we can start if these three are row 10, we will start from these three only first, then we will proceed to others, because we need minimum time. So we should start from row 10 once, and row 10 once, first row 10 ones will impact the most. After that, the impacted ones should be what I would say, should be processed. So that much is clear. This is very basic intuition, that you collect all the raw 10 and you start traversing, start to see the affected area, and after that go little deeper. For example, what I'm saying, you take this level, you make this level only. From this level you get this level, from this level you get this level. So in order to make this level, we are collecting first rotten orange. This level will impact some fresh orange. From that impacted fresh orange, what we will do, we'll again go deeper. We will have some other fresh oranges that will be impacted, and after that we will get our time, or all the oranges will be rotten or may not be rotten. So that much is clear. So we collect all the rotten in the queue and we traverse them one by one, and while traversing we will take a max tm, which will have our time. Why we are taking max tm? Because it's very computation type of thing, because using BFS we are using minimum. So whatever was the last thing, the last minute traversal we done, that is the required time taken. And also this is the array, not the array, this is the algo. And after traversing all that doing, if we will check if something, if fresh orange is left, what we do, we return -1, and else we return the max time. That much is clear. What we will do, collect all the rotten orange, traverse it, simultaneously have the time, and also what we do, if there are some fresh oranges, return -1, because we have done the traversal in the 4 direction as said. If not, if all thing is rotten, what we do, return the max time. That much is clear. And let's see the code. There are some things that I have to discuss. After seeing the code, we can discuss it. Yeah, this one is the question. So this is what we are doing. Basic thing, rows and columns. This is what I am doing is to go in 4 direction. It is very simple thing. If you go left, x is minus, y is 0. If you go top, what happen is x is 0, y is +1. If you go right, +1, 0. If you go bottom, 0, -1. So what I written over here is this value, this value, this value, this value, -1, 0, +1, 0, and DC 0, 1, 0, -1, 0, 1, 0, -1. And if you use these values simultaneously, you will go left, right, top, bottom. That's how I'm traversing in 4 direction. I declared a variable int fresh, you will get it. Also declared a vector visit, obvious reason, we should not visit again and again. I declare a queue of pair int comma int. Why I declared this, let me explain it. Int queue pair int comma pair int comma int. These are for row, column, and this is for time. That much should be easy to grasp. Let's go further. What we are doing, we are collecting, and also if grid is equals to 2, what we are collecting, row 10. So we push this inside the queue and also mark them visited. That is very basic. And if also, because we are going every cell, of the grid, we also, what we can do is we can count the fresh. How many fresh? How we get the fresh? If the grid value is 1, so we will simultaneously count the fresh. This is our total time declared. Basic traversing, what we do, we are getting the row, the column, the time. And very important thing, pop, we should pop. I always forgot and it goes to TLE. We are calculating the time over here, that much is clear. And we traverse in this column, we traverse in 4 direction. How we get the 4 direction? The row that we got, the point, this point, we got this row comma column, and we do this over it to get into the 4th direction. And we have is valid function. What is valid function does is, it should be inside the grid. So what we are doing is, row should be greater than 0 and row should be less than n. Column should be greater than 0 and column should be less than n, and we'll return a boolean value if something is true or false. This much is clear. And which direction we should go, we should not go in empty direction, we should go in fresh oranges direction. So that's what we are doing, fresh oranges direction. And also the new row and column should not be visited, because why visiting again and again, it will cause TLE, also time. And if everything is true, everything is correct, what we do is we push it inside the queue plus time and new column, new row, that cell is also inserted. And also what we do is make it visited, also decrease the fresh, because we have processed one orange, so decrease its size. We keep on doing, and we will see if fresh are greater than 0, if some fresh are left, because we count the fresh. If they are left, we will return -1. If they are not, we can return the total time. Total time is calculated over here. So let's see, let's zoom it out a bit and see if we can. This much is clear. I will try dry run. Which part I should dry run? Let's first take this part, the fresh part. Insert. We'll discuss it later. Let's have the test case also. Copy, paste, zoom it out of it. This is our test case. In this case, what this result will be, I'm not traversing one by one. It is a basic for loop. You can do it on your own. What this will fetch us is Q will be something like this. We have only one rotten orange, as you can see, two. Our vectors, our matrix something look like this. We have two only at this column, which is 0, 0. So Q will only have what it will have, 0, 0 with time 0 and mark visited. Let me clear. It will have something like this in the queue, because there is no rotten orange except this 0, 0. And also how many fresh over here, how many fresh? 0, 1, 2, 3, 4, 5 fresh, and we will have fresh is equals to 5 and visited 0, 0 is visited. 0, 0 is visited. Now we get to this one is popped. What we get? Row is 0, column is 0, time is 0. We popped it. Max TTL, before default value of TTL is 0, so nothing will be updated. We will go in the 4 direction. We'll go this direction. This and this will not be valid. In this case, they will never be execution. They will they will not go inside this block. This call and this call will be pushed inside the queue. So what are these? These are 1, 0, sorry, 0, 1 and 1, 0. 1, 0 and 0, 1. These will be pushed inside the queue with time +1, with time. Let me write it like this, with time. Yeah, this is the queue, and when it ran 2 times, fresh is now 3. Queue is something like this. After that, these two are processed. This one is processed. It will go here, up. These all 3 direction are invalid. We will this right. This one is popped. We will go right, and in right, what is the index? We will increase the time, and we pushed it inside this 2, 2 time 1, 1. How we get the 2 over here is very basic thing, time +1. In this, time was 1, we did time +1. That much should be clear. Now Q something look like this. Now we process 1, 0. Is it, this is visited also, this is visited also, so nothing good will be done. Only this will be rotten. And what we do, in which location? 0, 2. 0, 2 with how much time? How much time we have here was 1. What we do? +1 over it. 2 is equals to 0, 2. Q something look like something this, and when we pop this, time is updated. Now max time is equals to 2. Before it was 1, before that it was 0. Now it's 1, now it's 2. Now we process this one. Let me write it over here. 2 1 1 1 1 1 1 0 0 1 1. This is processed, this is processed, this is processed, this is also processed. We are at this 0 1 2 0 1 2 1 2. Now we are at 1 comma 1. We'll go here, 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 here. These are visited. This is none of use. We will go over here, and what we do after popping this 3 2 comma 1. Why 3? Because it was 2, and what we are doing over here is, while pushing it, time plus 1. And what else we have left? Again pop this. This is visited, this is none of use, out of bound, out of bound. Nothing will happen. We will process this. When we pop it, when we will pop it, we go this, we go this, we go this. And also when we pop it, 3 is greater than 2. Now it's 3. We will go right, and when we will go right, what we do is 4 comma 2 comma 1. This will be inside the queue, and when this is popped, what we compare is, we get the time over here. Time, we compare it with 4. 4 is greater. That's it. That's it. We'll again do the 4 direction: visited, not use, not use, not use, visited. And after that, nothing will be pushed. Queue is empty. We will get out, and what we will check, are fresh 0, are fresh 0. Yeah, they are, because as you can see, we have iterated all the ones. We just forgot about this variable. It is now 0. Is it greater than 0? No. So what we do is return the total time, and what we calculated the total time, it is 4. So I hope it is clear. Let me submit it and see if it is running or not. Yeah, it is running. I hope I was able to make my intuition very much clear. And yeah, it got a little long because of explaining. It is quite hard to explain graph problems. So if you did enjoy the video, so consider subscribing to the channel, liking this video, and you have to do what you have to do. So keep grinding. You guys are awesome. See you in the next one. Bye bye.